It's Sunday, and I'm trying to move some equipment around here in the shop and get it put away. Got some things moved there. But the old grasshopper starter engaged a couple times, and now it won't even spin. It's like it's not getting power. And I can get it to move, but I decided it's been turning slow. I want to get everything put back in here. It's been turning kind of slow, and even with the new battery, it's not ideal. So I decided to tear the starter down and see what looks like what. So this top part is the actual electric motor, and pull the end bell off of it and pull the brush assembly out here. I've already done that, just making sure the brushes move freely, which they do. So just double checking that. And I'm actually going to clean it up a little bit, but my main focus here is the Bendix assembly here, and that guy right there goes inside the that assembly. And what happens, there's actually on that rod there's supposed to be a spring, but I've got it off. That copper ring around the outside makes a contact. When a current is applied, it actually sucks this in to make contact. And there's a lug on this side, that's your constant hot feed from your battery. And then the other side goes up and gives power to the actual starter motor assembly when you turn that key. And when you release the key, it releases power, and this plunger comes back out, because when that plunger's in, it actually forces, you can see the gear come out there, and if that's not plunging in and out, that'll just spin. But it also, the way this is set up, from the best I can tell, and I'm not a starter motor expert here, but also when it pulls this in, it sends current to the starter motor to tell it to spin, and about every 10th time it'll actually go. So the reason I pulled it apart, you can see where that copper washer or ring makes contact. It's pretty crappy in there, so I'm going to clean those contact spots up. A lot of times I've seen where you can get parts for these electric motors. I don't have a source, especially on a Sunday. So I'm going to clean that copper ring up with probably some 180 to 320 grit sandpaper. So I'm going to put you guys on the stand here for the expose, and we'll see what we can do. That may or may not be the problem. There may be some other underlying problem in this motor, but that's suspicious at this point to me. So we're going to go with that. I've got a red Scotch brick here. Is one of my things, and I will get some sandpaper out. But I'm going to see, and I've done this before with other solenoid type plungers, to take this ring off, and I'm not 100% sure on how that works. So we're going to do a little investigative surgery here. This one looks like it may be a maybe non-serviceable. I'm not sure. Spinning the end of it there to see if it lets go, but I'd like to really put that copper washer on a flat steel surface with a piece of sandpaper on it to clean it, and let's see if I can't figure out how to disassemble this bad boy. It's just really not giving me any insight on how it comes apart. So I'm going to tinker with this, and when I figure it out, if I can figure out how to take it apart, I'll show you how that comes apart. So I'll be back in a few. So upon some quick research, thank God for the interweb there, it appears, first of all, this is a Nippondenso style starter. It's on a Kubota engine, so I'm quite confident it is a Denso. I can't find anything that shows that this part is actually serviceable to take that copper ring off. And I think what's happening with this is as it's supposed to be plunged in and make contact inside there. What's happening, quite frankly, could be that one of these spots on this ring and or the contact posts has got enough corrosion on it that it's not making its contact. So we're going to clean that up. I've got some 180 grit and some 320. We're going to start with a piece of 320 here that I sanded a little primer with or something at one point. And I don't know if you guys are in this picture or not. I believe so. And we're just going to try and clean up. And I have a feeling that the reason I like to use a flat metal surface for this is so that you're able to get rid of the pits. And I think we're going to have to go more aggressive. We're going to have to try the piece of 180 grit here. So we'll go ahead and go with that. And see what we end up with. See if we can't correct the problem here. I think what's happening, when that gets pulled in, it also sends power from that secondary post up to the starter motor, and it's not even spinning the starter motor, so it's pulling it in, but it's so crapped up it's not making good contact. Now these are not the worst contacts I've ever seen in a solenoid before. The panel beater, the dent pulling machine that I have is DC powered, and it uses a very large high current solenoid. I think it's capable of somewhere in the range of 600 to 1,000 amps. I can't remember exactly. But that thing had some huge arcs on it. And after cleaning it up, boy, did that thing work better. But that was in a previous video set. I don't remember if I actually videoed tearing it down because I was frustrated with it. And I figured, what did I have to lose, until I saw the price of the replacement solenoid for that thing. I think a replacement solenoid was like a couple $100. So we're just going to go ahead and clean this up the best I can. Go ahead and take that piece of 320 over it now. The brushes in this thing look fabulous, so I'm not too concerned that that's our problem. I knew this part needed done anyway, so even if this doesn't correct the problem 100%, we'll go ahead and put a voltmeter or a test light on this and make sure it's getting power every time I turn the key. And truly, this thing isn't in horrible shape. Again, I've seen much worse. So that's all polished up pretty good there. Like I said, it wasn't terrible, so this may not have been my culprit. The bearings are nice and free in the armature of the motor, so I'm not thinking that's a problem. I will take some Scotch-Brite over the armature of this motor too, just to polish that up a little bit so that it's not all carboned up. And that really isn't in bad shape. So, and you really don't want to drop one of these. If you drop this, you run the risk of cracking this armature, and it will be rendered useless. You don't want to set it down where there's a bunch of iron filings or grinding grit, because it has potential to pick that up. Same thing with the case itself. So next thing I'm going to focus on is these contacts down in here. see if I can do this with you guys watching here. Oop, trying to take the tripod with me. Now these do come out. I don't know that I really want to pull them out to clean them. I could. These are serviceable. We may try one side here and see how that all plays out. The problem is, it appears that that is soldered right there, and if that doesn't just slide into that hole, then we're going to run into some issue. So let's see what size these are. Looks like a 14 millimeter. Ooh. So just by taking that nut off, that contact should come out. And it appears there's a little rubber O-ring on it and an isolator inside the case there. So let's make sure we don't lose that. So I'm going to take this and we'll probably do the other side if I can get it out very easily. I just want to run into that thing constantly, don't I? I got a piece of metal here. I'll put my 320 grit on it, and I'll take and that appears to be doing a wonderful job. I'm going to take a piece of 180 grit though. That's going to take forever. Yeah, there's a real good pit mark in this, so we want to make sure that that's all good to go. So that we get complete transfer of power. Now you can see how quickly that goes. This is copper, so it's soft. Boy, that's really not wanting to focus, is it? There it goes. So you can see the top side's nice, the bottom side's still got a pit in it. So I'm going to work on that until I've got that where I want it. Trying to hold it as flat as possible on this paper, on the piece of steel that I'm rubbing it across. The other thing to keep in mind, that these contacts are sort of bowed up so that they make contact with the motor, or that ring. That's pretty much it there. You can see it's taking the pitting out. So I'll finish that up and I'll do the other side and I'll show you how to reset. You can see I've got both sets of those contacts cleaned up. I did remove them both. This little shunt wire that comes up here actually has a tab on it. I didn't notice, so that contact came out very easily. No problems. Had to splice a wire back together. It had electrical tape on it when I bought it, and the wire was had a couple strands broken in it, so just threw it back together there real quick. I'm going to hold this in my lap while I reassemble it here. I don't know that be able to see everything, but there is this spring that goes back on here. I believe you can grease that, but I'm not 100% positive on it, so I don't want to put grease on something that really wasn't greasy to begin with. So that's basically it. The plunger just goes back in its home with the spring on it, and there's a gasket around here. If this gasket is bad, I suggest putting some form of sealant on it. And that's about it. There's really no other parts to take out of that. I'm just double checking my bench here. And I've got three, let's see which ones they are. I believe it's those hex head ones. And I seem to have misplaced one, so we're going to find that here in a moment. Hopefully it's not inside one of these pieces parts. There it is, still inside the socket, so we'll go ahead and put these back on. I wouldn't say to over tighten these, just enough to squish that gasket just a touch. Because that case is aluminum. I always, when I want to tighten something less, I just put my hand over the top of the ratchet and don't grab the handle. Those also have a Phillips in them. You could probably tighten it with those, but when it's got a hex, I'll always use the other one and just be very careful. Now, the last thing I'm going to do is blow this end bell off, clean it up a little bit, and go from there. And I'm just going to use some brake parts cleaner on it. Nothing crazy. I don't want to get any type of I guess cleaner inside where there are bearings. So we're just going to spray this off real quick and hit it with some compressed air. Electrical parts cleaner would probably be a better choice, but I don't have any, so we're just going to go with this. It wasn't terribly dirty to begin with, so just want to make sure those brushes aren't going to hang up on me for whatever reason. They seem to move quite well. So I'm going to hit that with some air real quick here. And go ahead and put that back together. I'm sure I'll use a few choice words upon reassembly. Seems to be all good. Now I can't tell if this has had brushes put in it once before. The copper shunt on them has some solder on it, but I believe that's part of the assembly process. So you really want to get these brushes back in the same alignment as where they came out, and pay special attention to that. They've got these little spring clips that hold them in there. It's going to make it fun and interesting. I suppose that you could pop those off, but not knowing, they look like a starter recoil spring, and I really didn't want to fight them. And I suppose if your brushes are bad, I know you can get replacement parts for these. I've seen people actually rebuild them themselves. So I'm not sure if you could only go to the auto parts store. I know sometimes the box stores have a thing with motor brushes in them and things like that, and if you could match them up pretty close, you'd be good to go. So basically, I'm going to be fighting this for a while, I can tell, but you'll be popping those springs back inside so you can slide the brush in. So I'll do that, and we'll get this button back up, and I'll bring you back for a test. The starter is reinstalled on the piece of equipment that it came off of, and as you can see, it's in a different locale. So I'll give you guys a quick, I know it's dark in here, but give a little throttle here, a little glow plug action. So you can see it cranked right over real well, and it's only like 50 degrees here in the shop, so That worked out fine. I only started it long enough to move it back there, which is about 10 feet. So that's a little bit about how I tore that starter apart and diagnosed a weak engagement problem. And hope you guys enjoyed and learned a thing or two. I don't know a whole lot about that kind of stuff, but I kind of pick at it as I go. So we'll talk at you guys later, and next vid is going to be on the Duramax here. I'm working, you see I got a Sawzall laying on the ground. That pin right there that I couldn't get out from the other day, I'm actually cutting it off because I can get a Sawzall blade in there because there's a lot of play. I'm going to cut that off and show you guys how to get a pin out that's stuck in a bore. So I'll see you guys in a few.